In this video, we're going to be talking about applications of polynomial equations, and in particular, Pythagorean theorem. So, the Pythagorean theorem applies to right triangles, and it says if I have a right triangle, meaning there's a 90-degree angle, then the sum of the squares of the legs equals the square of the hypotenuse. So on that right angle, the two sides that form it are called the legs, and the longest side of the triangle is the hypotenuse. And you may have heard this formula before, but the square of the legs added together equaling the square of the hypotenuse is the Pythagorean theorem, and otherwise known as a squared plus b squared equals c squared. So we're going to use this formula to solve some problems. The first problem is the shorter leg of a right triangle measures x units. The longer leg is 7 units longer than the shorter, and the hypotenuse is 8 units longer than the shorter. So there's three things we don't know: the short leg, the long leg, and the hypotenuse. And the question is, which one do we know the least about? It says the short leg measures x units, so I don't really know anything about that. The longer is 7 units longer than the shorter, so whatever the shorter is, I need 7 more units. The hypotenuse is 8 units longer than the shorter, so again, whatever that shorter is, I need 8 units more. And now I fill those in for my A, B, and C. So the legs, remember, I have to square the legs, and that will be equal to the square of the hypotenuse. So x squared plus that whole quantity, x plus 7 squared, will equal that hypotenuse squared. Now we have to get rid of these parentheses, so we have to multiply that out. I have that x squared from the first x squared, and then don't forget that x plus 7 squared is x plus 7 times x plus 7. Don't try to distribute that square across the sum. You can't do it. You're going to lose your middle term. So if I remember to multiply it all out, I'll have x times x, 7x, another 7x, and 7 times 7, or 49. Same thing with that x plus 8 squared. It is x plus 8 times x plus 8. I need to remember to FOIL or box it out, but make sure I'm multiplying everything there. So x times x is x squared, 8 times x, another 8 times x, and 8 times 8. So there's all my pieces for getting rid of those parentheses. Alright, I'm going to gather up some like terms. I have x squared plus x squared, or 2x squared. 7x plus 7x is 14x, plus that 49. On the right hand side, x squared, 8 plus 8 is 16x, plus 64. Now, I have this polynomial equation that I'm trying to solve. I know some x squareds, it's not linear, so I have to get everything on one side and try to factor. I'm going to go ahead and move this x squared over to the left, because I want to keep my x squared positive. I have more of them on the left hand side. So everything is going to get moved over to the left hand side. I'm going to subtract x squared from both sides, subtract 16x from both sides, and subtract 64 from both sides. And look at what's left. 2x squared minus x squared, so 2x minus 1 would just be x squared. 14x minus 16x is negative 2x. 49 minus 64 is going to be negative 15 equal, that's 0, 0, 0, so it equals 0. I have a trinomial now. The front coefficient is 1, so I need factors of negative 15. They're going to add up to negative 2. I'm thinking 3 and 5. One of them has to be negative to multiply to a negative, and I need it to be the larger number, so it also adds to negative 2. Since that front coefficient is 1, I can go straight into my factors of x plus 3 and x minus 5. I set each factor equal to 0 and solve them. So subtract 3, I get negative 3, add 5, x equals 5. So again, we're talking about the distance of these side lengths, so legs and the hypotenuse, so it can't be negative. So I'm going to go ahead and throw that one out. Can't be negative. So that means that the shorter leg is 5. The longer leg is going to be 5 plus 7, or 12. And the hypotenuse will be 5 plus 8, or 13 units. So the side lengths are 5, 12, and 13 of that right triangle. Go ahead and try the next example. Alright, here we are. It says, the long leg of a right triangle is 17 feet longer than the short leg. The hypotenuse is 25 feet long. How long are the legs of the right triangle? Again, a triangle has 3 sides. We have the short leg, a longer leg, and the hypotenuse. In this case, we already know something about the hypotenuse. It is 25 feet. The long leg is 17 feet longer than the short. So I do not know anything about the short leg, but I know the long leg is 17 feet longer than the short leg. So whatever that short leg is, plus 17. Now I'll make it 17 feet longer. I go ahead and fill these 3 pieces into my Pythagorean theorem. The legs, so the sum of the legs squared, so the legs are on the same side being squared, will equal the hypotenuse squared. I'm going to go ahead and simplify this, so I still have that x squared. I remember that x plus 17 squared is the same thing as x plus 17 times x plus 17. I do not distribute that 2 across the sum. I have to multiply it out all the way. X times x is x squared, plus 17 times x, plus another 17 times x, plus 17 times 17 is 289, equals 25 squared, which is 625. I'm going to gather up my like terms. X squared plus x squared is 2x squared. 17x plus 17x is 34x. And I'm going to go ahead and move this 625 over to the left-hand side. So 289 minus 625 is negative 336. And that will equal 0. To make my life easier, because this is a pretty large number here, I'm going to start with the GCF. They're all even terms. They all have even coefficients, so I can factor out a 2. I'd be left with x squared plus 17x minus 168. So now I'm looking for factors of negative 168 that will add up to a positive 17. So I don't know much about 168 off the top of my head. I do know a divisibility rule that says if I add the digits and it's divisible by 3, then that number is divisible by 3. So 1 plus 6 is 7, 7 plus 8 is 15, and 15 is divisible by 3. So I know 3 will go in. 168 divided by 3 is 56. Well, that's not going to give me 17, so I keep looking. Well, I know a factor of 56 is 8, so 8 should go into 168. 8 times 21. Well, that's not going to give me 17. Keep going. Well, 8 and 3 went into 168, so 24 should go into 168. 24 times 7. I can get 17 out of that. So sometimes you just gotta play around. I play around with factors of the larger number, and then once I have the smaller factors, I know other things that are going to go in based off of what goes into those factors. Okay? So sometimes you just have to try it and play around with it. Now, I need it to multiply to negative 168. So one of these two things has to be negative. And since I want a positive 17 in the middle, I know the negative has to go with the smaller number to add to a positive 17. That front coefficient is 1, so I can go straight into my factors of x plus 24 and x minus 7. Then I set each factor equal to 0. 2 cannot equal 0, so that's not going to be one of the factors. X plus 24 could be 0 though, and x minus 7 could be 0. I solve each equation, I subtract 24 from both sides, get negative 24, add 7 to both sides, get positive 7. I'm talking about distance, so it's not going to be a negative solution, it has to be the positive 7. And in this case, positive 7 feet. And that was the shorter leg. So the longer leg, I'm going to go back up here. It's 17 feet longer than the shorter. So it's going to be the shorter plus 17, and I'll end up with 24 feet. I don't have to find the hypotenuse, it was already there. So the biggest issue I see with these types of problems is forgetting to actually multiply that out as x plus 17 times x plus 17 so you don't lose your middle terms. You cannot distribute across a sum. You have to multiply it out all the way.